Hey guys, so I'm going to solve question A of Codeforces round 769 due 2. So I hope you already read the question carefully. Now I will tell you the main intuition behind the problem. So you have given an integer n, the length of the string s, and the string is in the form of binary characters like 0 and 1. So you have to tell that is it possible to rearrange that particular string so there is not any substring in that string which is palindrome and whose length is greater than 1. So how will you will identify that given string s can be rearranged like this or not? So I will tell you the main intuition behind that problem. Okay. So how will you identify? You can take the case of any string. Like a string can start with a character 1 or either start with the character 0. Now you can divide. If you will move further, the next character either will be 0 or either will be 1. Same for the 0. Now the next will be either 0 or either 1. So if you will see, you will find here that this case will automatically be rejected because 1 and 1. This is parentomic substring here. Now if I will further divide this 0 into 2, 0 and 1, you will find that 0 0 substring. So this will also reject. 101 is also palindrome, so this will also be rejected. So only this substring can be created from here. If I talk about 0 0, this is rejected. 0 1. Now I will divide it into two, 0 and 1. So 1 1 rejected, 0 1 0 is palindrome. It is also rejected. This one from here, like 0 and 1. If I talk about length 1, obviously it is not palindrome. Only these four cases can be, or we can say like this is the strings where there is not any palindromic substring can be reached. Okay. So if I talk about the code, I can show you here. Like this is the code where you are given integer n and string s. You have to check like whether your n is greater than or equals to 3, then the answer will be no. And if the n is 2, then in both the cases the answer will be yes. And in the other case the answer will be no. If n is equals to 1, obviously the answer will be yes. So this was very simple problem obviously. So now we will move on to the next problem. Problem B. Okay, fine. So I hope you already read the problem from here. If you have not read, I will tell you the main intention behind the problem. You have given integer n, and you have to tell, can you rearrange these n integers, which are in the range from 0 to n minus 1. So the uh, XOR of any two adjacent elements should be minimum. Why minimum? Because the question is saying that the cost of construction is equals to maximum of any two adjacent pair. So if I will minimize that particular uh, XOR, then obviously the overall cost should be minimum. That was actually question wants from us, that you have to find the smallest construction cost. So if I will minimize all pairs XOR, then automatically the construction code will be minimized. Okay, so how I will do it? Okay, so I will draw it from here. Fine. Now I will take the case like if n is equals to 6, so the numbers will be 0, 1, 2, 3, 4, 5, and 6. Not 6 only up to 5. Okay, so if I write the binary of 0, it will be 0 0 0, 0 0 1, 0 0 1, 1, and obviously it is a 3, it is 4, it is 5, 0. If I talk about these four integers, third bit is 0, and if I talk about these two integers, third bit is 1. Okay, fine. So you can see, like if we will make XOR any two elements from this particular set, then its third bit will be 0, and you will make XOR of any two elements from this set. This XOR will be this third bit will also be 0, because third bit of both the sets are same. Like for this set 1 and 1, and for this set 0 0 0 0. But if I take two elements, like one from this and I take one from this, then definitely if I will make XOR, the third bit will be 1, means 2 to the power 2. So your XOR will be maximized here. We have to focus for not making this XOR when you are taking one element from the set of same zeros third bit and one element from the set which have third bit 1, but you have to write in them in a sequence. So definitely two elements, any two elements will be adjacent from both the sets. Now you have to focus to minimize that particular zone, which will be your minimized cost, because in this set, the third bit will be 0. So you don't have to be worry about others, because they will obviously less than 2 to the power 2. And if you will make XOR from here, it will also be less than 2 to the power 2. You can notice because third bit it will be 0. So the maximum which you are getting from here is 2 to the power 2. So how you will rearrange? So you will get 2 to the power 2 only here from here. I will tell you in the another file. Like okay, so 0, 1, 2, 3 are in one set and 4 and 5 are in other set. If you will make XOR from here, it will be less than 2 to the power 2. If you will make XOR from here, it will be less than 2 to the power 2. If you will make XOR from here, definitely it will be greater than equals to the power 2. Am I right? So if you want to minimize that particular zone, you can go up to equals to 2 to the power 2. How you can make it? Like if you will write 5 and 4, it will be less than 2 to the power 2. Obviously, less than 2 to the power 2. And 0, 1, 2, 3. This XOR is also less than 2 to the power 2. Okay. So if you will connect both of them, then definitely 0 and 4 will be XOR 4. It is equals to 2 to the power 2. All the other questions you have to do like that. You can minimize that particular adjacent XOR to that particular level, like third bit. All the other questions you will start I is equals to n minus 1. And you will check, have you got any integer with a power of 2? For that particular, after that particular integer, you can start other integers with 0, because this all will be less than this particular uh, rightmost bit. Obviously, you can imagine what I want to say from here. Now, from here, I can show you my code. This is my okay, so you are given an integer n, and if you will start I from is equals to n minus 1. So, using this particular thing, you can find the leftmost set bit, like uh, like we have integer 110. So from this, if you will use this particular thing, you will get integer x is 100, means the leftmost bit and the others are 0. So if your integer is x, it is the power of 2, and its leftmost bit is equals to itself, then we can say that this integer is in the form of power of 2, which we want to find, as I told you earlier. Okay, so you will check like I is equals to, if n is equals to 6, then I will be 5, and you will file like say out print 5. Now it will be 4. Now you will check, you will find the value of x, which is leftmost bit. Basically we are checking like x is in the power of 2 or not. So x will be 4 itself from here. So x is 4, I is 4, so you can say like it is the power of 2. So obviously we will print 4 here. Now I will start from the 0, and I will print the remaining elements, as I told you in that graph. Like I have printed 4, 5, then 4. Now it is in the power of 2. Now you can start from 0, 1,